Hi, I'm Dan Palumbo. Today we're going to talk about quick turns. Here's our scenario. We fly to an airport to pick up a client, we get some gas, and in 30 minutes, we want to fly back out. Are we really safe to take off again? Or should we let the brakes cool down a little first? Gulfstream states that a G4 with ASC 190, the carbon brake system, has a maximum brake kinetic energy, BKE, of 100 million foot-pounds, MFP. It's also important to note that if the energy level exceeds 85 million foot-pounds, the brakes must be inspected. But it's been demonstrated that we can go all the way up to 100 million foot-pounds. Well, how do we figure that out on the charts that are given to us in the airplane flight manual? Well, if you open up the airplane flight manual and you go to the G4 SP section, under Appendix C, you'll see all kinds of information about brakes, brake kinetic energy, and so forth. Our scenario today, which by the way is in the book, all I'm doing is breaking it down and showing you how to use the chart, has a landing weight of 66,000 pounds, so maximum landing weight, a brake on speed of 106 knots. That means we get onto the reversers and then we apply the brakes at about 106 knots. Our pressure altitude today is going to be 2,000 feet. Our temperature is going to be, well, it's hot, 30 degrees Celsius. Taxi distance is 1 mile and our taxi speed is 20 knots. Our projected takeoff, we're going to put as much fuel in it as we can. We're going to take off under gross weight conditions of 74,600, which gives us a V1 VR of 146. Our pressure altitude is 2,000 feet, and of course the temperature is the same, 30 degrees. Taxi distance is also the same at 1 mile. So let's get familiar with what's on this chart. On page 8, I believe, of Appendix C, you will see this brake kinetic energy chart and cooling times and so forth. Well, we've got the gross weight box up here. And this chart is from 40,000 pounds, 4550, 5560, all the way to 74,600. And it's got speeds. This is the brake on speed in knots. You've got 80, 90, 100, 110, 120. There's the 140 mark and the 150 mark. And notice that these lines are going diagonal. In some cases, they're even going almost horizontal. The next chart down is our pressure altitude. Notice there's a reference line here, and it goes from sea level to 5,000, 10,000, and 15,000. So if it's sea level, we're 1,000 feet, 2,000 feet, 3,000, 4,000, and 5,000. The next chart down is the ambient temperature in degrees Celsius. We've got minus 50, 0, and 50. And notice the reference line. The reference line is not at 0 or at the bottom. It's right here. But if you wanted to get 30 degrees as an example, there's the 0 line, plus 30 is 0, plus 10, plus 20, plus 30. There's the 30 line right there. The next chart is the taxi distance in miles. Notice the reference line for this is way down at the bottom. And again, we've got those diagonal lines. And it's got 1 mile, 2 miles, all the way to 6 miles if you're taxiing. That's probably San Francisco. Anyway, let's talk about our scenario. First thing we're going to do is land. 66,000 pounds, which is right here. Brake on speed of 106 knots. There's the 100 line, there's the 110 line, and it's just slightly on a diagonal position here. So right in between 100 and 110 is the 106. So we take 66,000 pounds and bring it right over to 106, and we go all the way to the bottom. We continue that all the way down to the next reference line on the next chart. And then when we get to the reference line, we have to look at 2,000 feet. So again, we're going on that diagonal line over to the right. So we've got sea level, 1,000, 2,000 feet, that's here. Bring it down to the bottom. Bring it to the next chart, straight down all the way to the next reference line. And there's the 0 mark, and there's our reference line, and there's plus 50. We need what? Plus 30, correct? So we're going to go, there's the 0 mark, we've got 10, 20, 30. Here's the 30 mark, so we're going to take from our reference line, diagonal to the right, to the 30 mark, and straight down. We go to the next chart, all the way down to the bottom, because the reference line here is at the bottom. All the way down to the bottom, and we're taxiing how many miles? 1 mile. So we're going to go diagonal, again, to the right, to this point, and come down. When we do that, we're going to look at a number that's about 40. In actuality, it's 40.5. So the brake kinetic energy is 40.5 million foot-pounds. Well, that only completes one part of our problem. The next thing we got to figure out is what the projected takeoff would be if we had to do an abort, and how much energy that would produce in the brakes. Well, we're going to go worst case scenario, obviously. Gross weight of 74,600, that's way up here, and a V1 VR speed of 146. So we're assuming we're going to go all the way up to just under V1, and now we're going to do an aborted takeoff, and we're going to say that that's 146. How much energy is that going to cost us to stop the airplane? Well, 74,600 all the way to the 146 mark. And how do I know it's 146? Because remember, we're going diagonal here. There's the 140 line. This is the 150 line. We go right in the middle of about 146. So that's going to put us right in this section here. Follow it all the way down to the bottom. Go all the way down to the reference line of the next chart. And what's our pressure altitude? The same 2,000 feet. We're going to go diagonal to the right. 1,000, 2,000 put us here. We're going to go down to the next chart, all the way down to the next reference line, which is not at the bottom. It's sort of like almost 3/4 of the way to the top. And our temperature is 30, right? So we're going to, there's the 0 line. There's 0, 10, 20, 30. So it's right here. So we're going to go all the way down to the reference line, and we're going to go diagonal up to the right and to the 30 mark, and then we're going to bring the line straight down. Going to continue to bring the line straight down to the taxi distance, and the reference line for that is all the way at the bottom. We're taxiing 1 mile, so we're going to go to the right and then bring it all the way down to the bottom, and that gives us a magic number of about 83 million foot-pounds. Well, what do we do with that? We've got 40.5 million foot-pounds to stop the airplane, and then we're figuring it's going to be another 83 million foot-pounds if we have to do an aborted takeoff at just below V1. Well, what we do is we add those together. Take 40.5 plus 83, and we come up with a whopping 123.5 million foot-pounds. Uh-oh. You're saying, wait a minute. Gulfstream says maximum demonstrated is 100 million foot-pounds, and you're absolutely right. So what do we do in that case? We take that 123, we subtract the 100 million that we're allowed, and that equals 23.5 million foot-pounds. What does that mean? Well, that means that if we come to this chart here and we see 23.5, and we follow this all the way down, it looks like we need to have a cooling time on the ground of 0.7 hours, or approximately 45 minutes. So here's the question again. You want to fly in to pick up your client, and you want to leave in 30 minutes. Under this scenario, would you be safe to make a takeoff? The answer is no. You would not be. You'd have to sit on the ground for at least 45 minutes. And that's how you use the chart. Fly safe.